My dear friends, today I am going to prove EM waves are transverse in nature. What do you mean by transverse? If the wave is propagating along this direction, and then if the electric field and magnetic field they remain perpendicular to the direction of propagation, mean wave is propagating along this side. If E and B they remain perpendicular to the direction of propagation, that means EM wave is transverse in nature. If the electric field or the magnetic field it oscillate along the direction of propagation, then it is longitudinal in nature. But we know very well EM wave is transverse. So how to prove it then? Okay, let's start. So this is a coordinate system: y-axis, z-axis, x-axis. Okay, I assume that EM wave is transverse. If EM wave is transverse, this is electric field along the y direction. It is increasing, decreasing sinusoidally, mean with sine function or the cos function. So it is increasing, decreasing, then going negative, then again going positive. This is a variation of the E field. Now in EM wave there is another field. It is the B field. It is along the z direction. Okay. It is also varying in magnitude and as well as direction. So this is how the magnetic field is varying. Okay. Both the fields they are perpendicular to each other as well as perpendicular to direction of propagation. Moreover, it is linearly plane polarized EM wave. Okay. Now wave is propagating along x. Now let's come to the derivation. The wave is propagating along x direction, right? Then this plane is parallel to this plane, YOZ plane. This plane is parallel to YOZ plane. Now in this plane, at any instant, there is some value of electric field and there is some value of magnetic field over this wavefront. So at any instant t, there is some E value, there is some B value. There is some constant E and constant B value. Okay. Now you know very well this is our Gauss law, right? Differential form of the Gauss law. Now the EM wave is propagating in a space which is there is no medium, free space, or maybe it is an air. And if there is no charge density in free space, then rho equals to 0. So delta E equals to 0. Now what is delta vector? I cap curly by curly x, j cap, the k cap. And what is E? E is having component in all the directions, because I don't know whether its nature is longitudinal or transverse. So I assume that E is having all the components along x, along y, along z. Having all the components because I don't know what about the nature of EM wave. Now then, this is the dot product, I cap dot I cap 1. So this becomes the relation. Now I am coming to this relation for this wavefront. Here EY and EZ they are fixed, and at any instant and at any place, at any particular place, and at any instant t, EY and EZ they are in the yz plane, so they are independent of then y and z. They will not change with y or z. Okay, because there is some fixed value, constant value in y and z. So they are not changing with y and z. What it implies? Curly Ax by curly x equals to 0. This is our first equation. Remember. Now coming next, this Maxwell equation, the monopole does not exist. Okay, del dot b equals to 0. Now again del vector and b vector. Again suppose b vector having all the components bx, by, bz. Open the dot product, it becomes this. Again by and bz, they are in the by and bz in the yz plane, having the fixed values. If they are having the fixed values, they turns to be 0. So here becomes curly bx over curly x 0. And you know what is bx? Bx is mu into hx. So mu into curly hx over curly x 0. But mu not equals to 0. It implies curly hx over curly x 0. Now coming the next Maxwell equation, where because of the conduction current, displacement current, there is the magnetic field. But for the free space, there is no current density. So this turns to be 0. And we left only equals to this. Okay, B having all the components again, bx, by, bz, and this is a matrix. And here E having all the components. Now open the matrix. So we are having the 9 terms, 2 plus 2 plus, 2 plus 2, 6 terms, equating 6 terms with this, and comparing the components of I cap, j cap, k cap. Again, because bz and by, they are in a wavefront, in a y or z plane, they are not varying with y and z, they turns to be 0. That implies this equals to 0, this equals to 0 means curly Ex over curly t equals to 0. Remember. Now I am coming here. The Faraday law, Maxwell equation, rate of change of magnetic field causes the induced EMF with negative sign because of the opposition. Okay, that induced EMF produced in such a direction that it opposes the cause which produces it. Again, all the components, they'll open it, matrix, and you are having 6 terms again, and this also having the 3 terms, comparing the components of I cap, j cap, k cap, you are having these 3 equations. Now again, Ez and Ey, they are in a wavefront, in a y or z plane, they are not varying, they are constants with respect to y and z. So it implies this equals to 0, it implies this equals to 0. From the 2 equations, we are getting this thing that curly Ex over curly t 0 and curly Bx over curly t 0. What it means then? It means if E is having some component along x-axis, B is having some component along x-axis. Remember, the wave is propagating along x-axis. And if there is some component of Ex, there is some component of Bx, then they are not oscillating, they are not oscillatory in nature because their time differentiation is 0. But not oscillatory mean no wave. No wave mean it implies the Ex itself 0, Bx itself equals to 0. That means there is no component along the direction where the wave is propagating. That it is not longitudinal in nature. No longitudinal nature. Because here there was two possibilities. Whether Ex is independent of time, Bx is independent of time. That becomes the non-oscillatory wave. If non-oscillatory wave doesn't mean any wave. So second possibility is Ex itself 0, Bx itself 0. It is okay. So electromagnetic wave is not longitudinal. Now we have to probe next thing. It is not longitudinal. Okay, we proved. Now we have to prove E and B are perpendicular to each other. Now how it is so? Now I'm again coming here. You know the three equations. These six terms equating with the, these three terms, okay, and this becomes, equating I cap, J cap, and K cap. Now we just proved B is not having any component along x-axis. Mean there is no Bx. This is equals to 0. And there is no Bx. This is no Bx. This is equals to 0. So I follow this equation and this equation. And it is 0, it is 0. So what we are having now, like if this is 0, minus curly bz over curly x equals to this, like this one. And when bx 0 here, this term equals to this, so having this one. Okay. Now coming to the electric field. Now there is no component of Ex, so there is no term, so only this equals to this, so that it is here, and there is no Ex, this equals to 0, that means this becomes equals to this. No Ex, no longitudinal nature. So I am having this and this equations. So they are the four equations. Now dividing this equation by this equation, dividing the two. So dividing the two, this cancel with this. Okay. So what happens? This turns to be with minus sign, because curly x and curly x is there. It means bz over by. And here curly t and curly t is here. It implies ey upon ez. So cross multiply and rearrange, it becomes ey by plus ez bz equals to 0. That means if you open the dot product, you will have ex bx plus ey by plus ez bz equals to 0. But we already proved there is no longitudinal nature, no component of E and B along x-axis. So what we left? Only the two terms. That means this can be written like this. That means it is EB cos theta. Okay, what is EB? Mean you know very well. If you remove the dot product, you are having these three terms. But this is already 0. Then you are having the two terms. They are the same, like mean this one. So EB cos theta. That means if this is 0, what it implies? Theta equals to 90. Theta 90 means E is perpendicular to B. So I proved that E is perpendicular to B. That electromagnetic wave is transverse in nature, like this A and B there, but they remain perpendicular to each other. Okay, thank you very much. And if you have any doubt, please write in the comments box. You may note down my phone number 9888 169 226. Okay, thank you very much.